thank you all for showing up. Thank you for the opportunity, Jeff, and the IO friends here. My name is Thiago Custódio. Currently, I'm living in Houston, Texas, but I'm from Brazil. And today, I would like to talk a little bit about Azure Functions. So the idea is to cover since the basic things until some best practice, and hopefully it will be helpful for you guys. As I said, in case you have any question, feel free to write in the chat window. Otherwise, I guess if you want, you can open your mic and ask the question in case you're not shy.
Hey, Tiago, let me just ask anyone, does anyone hear that popping or is it just me when Tiago speaks?
Yeah, I do too.
Yeah, slightly.
I don't know if
it's not bad. It's just a little
it's
bit.
not bad. I don't know if you're popping in the mic there, Tiago, or there's a loose connection. We can make do, you know, if we can't resolve that, but there's a little bit.
No, actually, let me try a different mic. Just a second.
He's got his own recording studio there. Let me try mic number 5.
I thought it was okay. Let's see.
Meanwhile, I have one question, either of you people. I'm a SQL DBA basically, and I'm planning to find a good book to read about Azure. Is there any good book?
A book? What's that? You mean the
Oh,
paper?
Yeah, I am old school.
What I always tell people is Microsoft has a partnership with Pluralsight. So if you do a search for Pluralsight Azure training, you'll see a free link. And I think those online, because you get to see hands-on, it's more up to date than a printed book, because Azure is always adding new features and new capabilities. But I would encourage you to check out Pluralsight. Tiago, do you have any recommendations for anyone who's wanting to learn Azure in terms of best sources of information?
Yeah, the best one is docs.microsoft.com. And the reason is because it's created by Microsoft people. So whenever they release a new feature, they create a documentation over there. So even if you are MVP or not, you won't be as fast as Microsoft employees, because this is part of their job. Okay.
Yep.
I'm still trying to solve the audio issue. Just a second. Sorry about it. It seems that it's... Is it better now? Yes.
Speak a little bit more.
Hi. Can you hear me better?
Yeah, that's an echo. It sounds like you're in a reverb chamber.
Oh no, yeah, it's because of the... Let me try something different. Is it better now, or is it still with echo?
Personally,
No.
I think the popping might be better than the echo, but that's just me.
I'm sorry, guys.
It's okay.
Yeah, what is going on? Maybe it's my Zoom or my internet. Who knows?
Sam, what do you want? Do you want the pop, or do you want the echo chamber?
Mic?
The echo chamber. Let's do the pop. Paul. Yeah,
Okay.
leave it at that. Shouldn't be too bad.
Sorry about it.
Yeah, no
I'll
worries.
try
Oh,
to-
good. Don't worry about it. It's fine. Technology fails us sometimes. More
Okay.
often than not for me.
So in case there was a brutal internet problem, let me know and I'll try to repeat. Okay?
Okay, great.
Okay, so as I was saying, my name is Thiago Custódio. I'm originally from Brazil, but now I'm living in US, here in Houston. I was talking about this conference that we organize called MVP this year will be online, and unfortunately, most of the talks will be in Portuguese or Spanish, but we do have plans to run in Europe next year, and maybe in US as well. So keep an eye on that. And I'm also the writer of these two books. I think it's useless for you because it's in Portuguese, but one it's about Azure, the other one about cognitive service. And so the agenda for today, I'll cover these three topics, not exactly on this order, but we'll talk about a little bit of security, best practice, and performance, okay? But first, I assume that not all of you are familiar with serverless and what it means. There are a few definitions over there. Unfortunately, there's no one that everybody agrees. However, you can find those three ideas in each one of the definitions. Okay, so the first idea is the abstraction of servers. When we think about serverless, we kind of think that we don't have servers anymore, right? But that's wrong. The thing here is that we don't care what operational system we are running, how much we have memory and things like that. The second idea is the event-driven scaling. So it means that if your application receives more events, or less events, it will scale up or down. So the number of events will be the unit of scaling of your application. And the third one is the sub-second billing. Okay, so it means that we will only be charged if and by the computer resource used on this event. And as the benefits, the first one is the micro pricing. So you will only be charged in case your application consumes the event. The second benefit is that it's easier to scale because basically you are delegating this to the cloud provider and they will take care of this for you. And the main one, in my opinion, is that you put all your focus in terms of business competitive rather than infrastructure. Okay, so to me, this is why I believe that serverless is the natural evolution of cloud computing. Okay, and just to prove that this is the present, not the future anymore. Last Ignite, Microsoft announced a few APIs for Cosmos DB. Now you can work on this pricing model. Besides that, in previous events, they already announced SQL Server, Postgres, sorry, and MySQL. You can work in serverless models for them. Redis and MariaDB, sorry, we don't have serverless offers yet, but hopefully we'll have in the future. Okay. Talking about serverless on Azure, we have a couple of services available. Usually we refer to Azure Functions, Logic Apps, and Event Grid, okay? And most people, they also think that once you choose a cloud provider, you basically have a lock-in with this cloud provider. This is not entirely true. If we are talking about Azure Functions, for example, you can run on premises, you can run on your Kubernetes cluster, you can run on other cloud providers. Of course, if you're using it integrated with other Azure services, you won't have this integration. Someone put a message in the chat window or not really? I can see the chat window. Okay, I'll take a look on this later.
Tiago, someone was just asking if we're going to share the slides. Are you okay if we share the slides with everybody? I know we're going to do the recorded presentation, but if we could have the deck also, that'd be great.
I'll send to you guys later, and you can share with the attendees. Is that okay?
Okay. Yep.
Yeah. Thank you.
Thank you, Jeff. just to talk a little bit about Event Grid, the idea of the service is to be a repository for events. And the events, they can happen in your Azure subscription or outside of your Azure subscription. So imagine, for example, you want to notify that something happened in your e-commerce application, for example, you can publish an event on Event Grid, and then you enable Azure applications or other applications to consume these events and react to it somehow, okay? The beauty is if you use in Event Grid with the Azure service like blob storage, for example, or something like that. In fact, the Event Grid is what enables the integration between storage accounts and Azure functions, okay? And then the Azure functions subscribe to Event Grid and consume the events for you. Now talking about Azure Functions. Azure Functions is a service that it's available since 2016. It's an evolution of the Azure Web Jobs SDK, but they add support for more programming languages and more bindings. I'll just explain what it means. But the idea is basically you write code in your favorite programming language, and then, just a second, let me fix this. You write code in your favorite programming language, and it will react, it will get triggered based on some event. Here in this table, we have a few of the possible integrations between Azure Functions and Azure services, as well third-party service. So for example, you can use blob storage, Cosmos DB, Event Grid. Let me just write in here. Cosmos DB, Event Grid, Event Hub, HTTP, IoT Hub, as well some services from Microsoft Graph, for example, and third party like SendGrid, Twilio, for example. Those are the possible bindings, okay? Oh, possible triggers, sorry. And we have basically two possibilities, input bindings and output bindings. So the binding is something that it's available for you. So for example, if you're using the blob storage as the trigger, you can write a function that will get triggered whenever a new blob is stored in your storage account. So let's imagine that we are talking about images. Whenever someone uploads an image to your storage account, you can have an Azure function to resize the image and store the new image somewhere, for example. So the input bind will be the array of bytes related to that image, for example. So rather than you to write the code to connect to the storage account and read the image, it is already injected in your function for you. And the same if we are talking about output binding. So imagine that your Azure function performs a kind of computing. You can store the output using output bindings. So for example, Cosmos DB. You can store the output on a Cosmos DB collection without actually you connecting to Cosmos DB and persisting the value in the collection. Okay, so that's the idea of the input and output bindings. The code to connect to those services is already available for you. At this moment, you can write your Azure function using C#, Node, F#, PHP, Java, PowerShell, Python, TypeScript, okay? Those are the official supported programming languages. However, if you need, you can write your function using a different programming language. For example, there is one Microsoft employee. He is called Anthony Shu. He wrote some samples of Azure functions written in COBOL, in Go, for example. So how you do that actually? The function host will call the code that you wrote in a different programming language. So the function host is something native from Azure Functions, and your code, it will call your code and that it's written on a different language. So you use the trigger and the bindings natively, and then it's pretty much like calling your service running on a different programming language. Okay. And lastly, related about Azure Functions, you basically have consumption plan and app service plan. The difference here is that if you want the serverless approach, you should go with consumption plan, or where you only get charged in case your function get triggered. However, if you already have an app service plan where you host your ASP.NET Core APIs, for example, you can also host the Azure function there. The difference is that you already pays for the app service plan related to, I mean, you already pay for this app service plan, okay? Whether you receive events or not. Talking about security, assuming that we are talking about HTTP trigger Azure functions, the idea is that you never expose directly your Azure functions, okay? But you put an API gateway in front and you expose the routes from the API gateway, okay? And you do that to protect your APIs, final APIs, and then in case you need to change something here, you won't need to release a new version of the mobile app, for example. Okay, and also talking about API gateway, you can do you can block unauthorized requests. You can generate keys for specific customers, and then you can monitor how many calls you received from that particular key, or you can also block requests from IP addresses that you are not you basically don't recognize, for example. Okay, and the communication between the mobile app until the API gateway, and from the API gateway until your Azure functions, everything is encrypted. So there's no risk to attacks like man in the middle or things like that. So the service that implements the API gateway on Azure, it's called API management, okay? And besides everything that I just spoke, you can also perform versioning on it. So imagine that you are evolving your APIs, and for some reason you need to break the contract, right? So you basically won't change that in production, but rather you generate a new version, and then you let your customers to switch from version 1 to version 2, or from version 2 to version 3 whenever they are ready, or until you decide that you no longer support older versions. Okay, so you basically let them migrate to newest version when they are ready. Another good practice related to security is the usage of managed identity. So managed identity are accounts that will be created inside your Azure Active Directory. And you basically go to your Azure function, you find the identity icon. Once you click on it, you basically will see something like this. There are two types of managed identities: system assigned and user assigned. You basically switch the status from off to on and hit save, and that's it. This ID actually represents a GUID that will let you find this managed identity if you need inside your Azure Active Directory. And why you do that actually? Because you can grant access to Azure service to this particular identity rather than rely on connection strings. So for example, assuming that you have a function and you have a SQL server, you don't need to use the full connection string. Okay, you use the connection string just to specify the initial catalog and the server basically, but the user and the password you don't need to specify because there will be the managed identity. So in your SQL server, you grant the managed identity to connect to it and to read and write data to the particular database, and that's it. In case the connection string got leaked, there's no risk because the attacker won't be able to impersonate this identity because it only lives inside your Azure Active Directory. Okay. Another good practice here related to security is the usage of Key Vault. So Key Vault is a service available on Azure to let you store securely your encryption keys, SSL certificates, and secrets for your applications. Here is a sample, for example. Rather than you store the secret of your Azure function in plain text in here, right? What you do, you move this configuration to Key Vault, and it will encrypt this content and generate an URL for you. And what you do, you use what we call Azure Key Vault reference. So basically you specify, rather than the content in plain text here, you just put at Microsoft.keyvault, and then you specify the URL for that secret. Okay, this is called Azure Key Vault reference. So all the job related to authenticate against Azure AD, grab one access token, and then retrieve the secret from Key Vault using this access token. Everything is performed by this Azure Key Vault reference. Just one thing that I would like to highlight, in case you isolate your functions using VNets, for example, you need to guarantee that this communication between the function and Key Vault will be enabled. Okay. Talking about best practice, but related to how you write your Azure functions, okay? The first thing I would like to recommend is what we call S.O.L.I.D principles. The S.O.L.I.D principles, you can find more information about them in this book, the Clean Code book by Uncle Bob. Okay, and the principles that I would like to highlight are the S1 and the D1. The S1 stands for single responsibility principle. So what you need to do is make sure that your function is doing one thing and that's all. Here are some sentences from the book related to this principle. So functions should do something or answer something, but not both. One way to know that a function is doing more than one thing is if you can extract another function from it with a name that is not merely a restatement of its implementation. So those were some tips for you to identify if your function are doing more than one thing or not. However, don't use this as a golden rule. You know, it's just a recommendation to make your life easier. And but sometimes it's not worth to break into multiple smaller steps. It varies from case to case. Okay, I'll talk more about this later. Don't worry. And the D principle stands for dependency inversion, actually. However, one way to achieve this principle is by the usage of dependency injection. So the idea here is that your function will receive the dependencies rather than you instantiate the dependence directly in the code, okay? The benefit of the dependency injection is that you can replace the instance that you are injecting, okay? And you can also specify the life cycle for this dependency. For example, in case you have something that it's really expensive to create all the time, you can specify that the life cycle is singleton, and then this instance will be shared among all the instances of your function, okay? One common example of this, not only related to Azure Functions, but ASP.NET Core in general, we no longer instantiate HTTP client, right? We receive an instance that will be created by HTTP client factory, okay? This is one example of this. Talking about performance, there are a few tips here. The first one is to monitor how bad or how good your function is answering the requests, or you can do that basically based on aggregated requests, or if you want, you can enable the live metrics. The live metrics used to be enabled by default. Now you need to enable, and then you can inspect what is happening in your Azure functions in near real time. I'd like to talk about durable functions now. Durable functions, it's a framework that will add more features to your Azure functions, okay? The first thing, it's what we call function chain. The idea here is, for example, whenever the output of one function will be the input of the other function, right? You basically persist the output in a queue or somewhere, then the other function get triggers and so on until the end of the workflow, right? Using durable functions, you can achieve this scenario in a very simple way. For example, here is one sample. Basically, all you have to do is split your workflow between activities. Okay, so in this sample, we have basically 4 steps: F1, F2, F3, F4. And the output of F1 will be the input of F2, and so on until the end. So basically, when you specify that the output of this function, sorry, basically what you have to do is just set a waiting here, and then the framework will monitor if the task is completed or not, and in case it is, then it triggers the execution of the next one, okay? Another scenario that durable functions enable, it's what we call fan in, fan out. So the idea here is that you fire requests, multiple requests at the same time, and then you only proceed to the next step when you received all the response, basically. Okay, so here we have F1. We fire 3 requests, of course, passing different parameters to F2. Okay, and then when we receive the response from all those tasks, we trigger the execution of F3. To demonstrate this, you basically have a loop here where you set how many times or how many activities you trigger. In here, we have a list of tasks, okay? So you start this activity, you add to the list, and then you await for all the tasks to complete, and only then you proceed to the next activity, okay? So as you can see, it's pretty simple to specify this workflow using the code, right? And in addition with durable functions. Another idea here, whenever you need to trigger a function that you know that will be a long running one, you can start the execution, and the framework will provide an endpoint where you specify the unique identifier for that execution, and then you can monitor if the work is completed or not. Okay, so a scenario like this, it's automatically enabled and implemented by the durable function. It's a very nice one. I use it many times. For example, imagine that you have to perform a transformation on a very large image, or if you want to basically shrink a particular very large file or something like this, that you know that you will take quite some time, you don't block the user waiting for everything to complete. You basically specify, hey, whenever you want to figure out if it's completed or not, you can check this endpoint, for example. And also, you can use durable functions to await whenever something happens. And this something can be an external event, for example, the approval of something by a manager, for example. Okay, I don't have code for this one, but the idea here is something like this. If we come back to the fun in, fun out one, there's one other signature where you can specify a timeout. So you basically await until that timeout expire, and when it expires, you basically abort the continuation of the workflow, for example. And lastly, let me talk a little bit about some public use case that use not only Azure functions, but as well durable functions. The first one, it's a company based in Spain. They, just a second, sorry. Sorry. So Fagor Ederlan, they are a company based in Spain. They basically, they create auto parts, okay? So they have these huge machines over here, and previously, they basically produced the auto part and they pass to a kind of quality assurance team or something like this, right? And now what they do, they are extracting the data from those machines and they are sending to the cloud. Okay, so they use a bunch of Azure services in here. They are using Azure IoT Hub as the entry point. So it will receive the telemetry data. They are performing some kind of transformation using Azure functions and storing the final output on Azure tables, okay? And also, they are using string analytics to enable real-time queries, okay? And using Power BI to display the output, okay? And in case something is really bad related to that particular piece, they send an event that will communicate again to Azure IoT Hub, and it will send back whatever they need to stop a machine, for example, or something like this. Okay. The second case that I have in here It's Fuji Film in Japan. So they have this application, which is a catalog of baseball matches and baseball players, and they let users to purchase professional pictures from a particular game, for example. What they do here, whenever the pictures got uploaded, they are performing some kind of processing on top of those images. So they are using here Azure Functions with storage, blob storage, sorry, input binding, and as well blob storage trigger. So it triggers this function, which will be related to resizing, rotating images, and things like that. Then once they produce the new image, they basically trigger the face API function, which uses the computer vision part of the cognitive services to recognize who is the player on that particular card, for example. And they also have other functions in here to train whenever they have more players and things like that. And finally, they store these also on an analytic database. And my favorite one, finally, it's the Have I Been Pwned? I don't know if you ever heard about this, but this is a company created by another MVP called Troy Hunt. He's Australian one. And he basically created a very large data set for data breaches. So for example, I won't say the name of the companies because I don't want to have any problem, but you can see that there are very large players in here, and they already had problems with customers' data that got leaked, okay? So the Have I Been Pwned is basically a database that will store data related to these data breaches. So it's something like this, for example. They created a few APIs, sorry, and you type your password, and you can check if this password already appeared in a few or in one of the data breaches that they have on their catalog. So basically, the password is hashed, and then he double check if the hash appears and how many times it appears. So for example, password 123 appeared 615 times in different data breaches, okay? And that's it basically. So this is just to make sure your users are creating safe passwords and not very common ones. So that's the main idea of this service. And it's not only an API, but you can also use or add extensions to your favorite browser. I remember there are for Firefox and Chrome, if I'm not wrong. So if you want, you can enable this extension, and before you create your next username for some website, you double check if the password is safe or not. And why I would like to talk this case in particular is because the Azure functions, you're basically they basically will charge you on top of these two variables here, the execution time and the total executions, okay? So the execution times, you will be charged this amount, I don't even know how to say it, according to gigabytes per second, okay? However, the first 400,000 gigabytes per second are free. And the total executions the first 1 million are free, and you pay 20 cents of dollar per million of executions. Okay. So Tryhunt, he created a blog post last year, so the numbers are not updated. Okay. Here is just a sample how much it will cost you based on this that we just talked about. Okay. So in here, imagine that you had 500,001 executions in a month. Remember that the first one is free, right? And the next 1 million, or the next each million, you pay only 20 seconds. However, 500,001 is less than 1 million, so it means that based on this variable, you won't be charged, okay? So it costs you 0. And the execution unit, he had okay, in this example, 7,179 gigabytes per second, and the first 400,000 is free, right? So simple math here, this sample is also free. The cost here is only related to the reads and writes in your blob storage. So those are the samples, okay? And as well, the network out to transfer this data. So in this example, according to those variables, it will cost 78 basically cents per month, okay? Now, real numbers that he provided also on his blog post, but this is outdated, okay? Nowadays, he's probably like 1 billion requests per month. But on that time, it was like 140 million executions, okay? The first 1 million is free. So you'll be charged this, right? And you divide this per million times 20 seconds, the execution count will be $27.98. The execution unit that he had was 2,028,000 gigabytes per second. The first 400,000 is free. So the billable units is the difference between these two, and you multiply by the amount. So the execution units, it was $26.05. The reads and writes in the storage account, okay, and then the network out. So on a particular month in the past, he had like a bill of around $280 to support 140 million requests, which is quite impressive, right? So how exactly he saved a lot of money? The secret is that, for example, let me just go back a few slides. Because the data is already stored in the way that will basically makes the reading easier, right? What he did, he created several units of these hashed passwords, and it's being delivered by CDNs, right? So most of the requests, they don't even get to the Azure function because it's already pre-calculated, okay? He explained more details about this, but in summary, these 140 million executions in here, they were basically, they didn't exist in the CDN files, and for future executions, there will be a copy over there, and he will save even more money. That's the main idea. So this was the content that I prepared for today. The idea was just to highlight good practice and exemplify some real scenarios of public cases that Microsoft basically they have a website where you can query for this particular service which customer is using this, and there is a story related to that particular case. I'll share the link with you. So this is the last one that I was talking about. So microsoft.github.io, tech case studies. You can find those that I presenting here and many more. Someone asked, where is the best way to learn about Azure or more about Azure functions? The recommendation is docs.microsoft.com, and as well docs.microsoft.com/learn, because basically Microsoft have professionals that will create this kind of content. At the same time, the engineering team is creating new features, so there's the up-to-date content. The Azure Functions team in particular, they host some lives every month. Basically, you can find the official YouTube channel in here, so bit.ly Azure Functions YouTube. This month, I can't remember if they already scheduled, but if you go to this link, you can watch the previous one. And in case you need, here are my social networks, the easiest way to get in touch with me and to learn more about Azure, because I basically share a lot of things about Azure. And that's it. I'll let you ask something, or in case you need more clarification about what I present today, just let me know.
Hey, Tiago, if you want to read in the chat window, Nate Jenkins had a question about managed identities.
That's terrible. They guessed my password. Gotta change it now. Managed service account, correct? We have no access to update and change the credentials. Yes, you won't touch that actually. Basically, once you create the managed identity, one object will be created inside the Azure Active Directory, and there's no password assigned to that. You basically, for example, if you want to access Key Vault, you go to Key Vault and create an access policy where you grant this particular identity can get and list secrets, and that's all. There's no password involved. Whenever you want, you can revoke the access in Active Directory, and that's it. Question on functions execution cost. What does it mean by GBS? How do I measure GBS? This is a very good question. So there is no standard in Microsoft. So for example, if we are talking about Cosmos DB, the unit will be RU, resource units. What is a resource unit? It's a metric that they created. SQL database, which is the past version of SQL Server. There's no RU or GBS. They use what they call DTU. What it's a DTU, I don't know. So those are metrics that they created to measure the consumption. So somehow it's related to the CPU and the memory usage of on the process of that particular transaction or event, something like this. And GBS means for gigabytes per second. So it's pretty much what I just said. They measure the amount of CPU and amount of memory used to produce the output that you need, for example, and they charge per second. So the idea here is, if you remember the best practice that I mentioned related to the single responsibility, it's better if you have more functions that process really fast, because the GBS will be, fewer than if you have only one function that does everything. So when you divide and conquer, you pay less. That's the key takeaway from here. What is this? I also like Season of Serverless, just found about it. Yeah, so from time to time, people, they create some kind of campaigns. So we had Serverless September, there was October or something like this. And I don't know about November, I don't know about December, but the idea, from time to time, they create a campaign that basically help you to get started and get involved with those services. There are many initiatives. There was a colleague, also MVP, Gwyneth. She created a kind of serverless university. I don't think they will create more, but you can double check on Twitter. If you check serverless university hashtag, you can find more content about it. And as I said, if you go to microsoft.com/learn, there are a few learning paths over there, especially one related to serverless, where you can learn all about Azure functions and use some of the available triggers, some of the available bindings, so you can play a little with Azure functions.
So Tiago, I've got a question for you. If you look down the
Feel free.
road in your crystal ball, 4 or 5 years down the road, do you think serverless at some point will cause a lot of companies that are on the Kubernetes bandwagon, the containerization bandwagon today, and people stop looking at that and some of the associated complexity for microservices and move more into the serverless environment? Do you see any overlap between Kubernetes and, a robust serverless infrastructure down the road?
Yeah, this is a very good question. Let me see if I can find something very fast here, because it's related to your question. Just give me 1 second.
Okay.
Someone published on Dev2 once a very interesting article related to the cost of serverless. Let me just see if I can find it really fast. Just give me 1 more minute.
Or Elliot, if you wanted to comment on that.
Don't do him like that. That's just rude.
I'm giving him a chance to flex his tech chops.
He'll blame it on the lag. I didn't hear that. Yeah. Blame it on his internet. You're still on mute. You're on mute, mate. You're digital
I'm just
dinosaur.
nodding like, yeah, I hear you.
I could not find the link anymore, but the thing is, let me try to explain what was in the article.
Okay.
So there was an estimation how much it would cost to write some piece of the Facebook using serverless, right? And because they received like billions of requests, and based on the those variables that I described, the execution count and the the function, sorry, what is the name once again? The GB per second related to Azure Functions, it will cost like $1 million or something like this per month, which is something really expensive, right? So in summary, you need to measure how many events you're expecting to produce, okay? Because if we are talking about this sheer volume, maybe serverless using a provider like Azure Functions won't be the cheapest one, because you basically will, use all the resources they have available, and you need to pay for that. So it will be cheaper if you do on your own using your Kubernetes cluster, or if you use any other service.
Yeah.
But answering your question, 5 years from now, what I believe, there is a movement called low code, which is kind of what we have with lodge caps. So there will be even more companies and providers offering really simple ways for you to automate things, just drag and dropping things and connecting things, right? There will be an expansion of this movement, in my opinion. But for very large players like Facebook, Netflix, where the number of users, the number of events, it's something like very, very, very big. I can't imagine they replacing what they have by something related to serverless. But it works really good if you really need to ship things fast, like startup, or, well, I can't answer without a context, but I think kind of explain. It will depend on your context, basically.
Well, I think a lot of the concerns that I sometimes hear from our customers at my company is serverless locks you in, right? Serverless on Azure is not serverless on AWS. And so to a great extent, you're kind of saying, I'm going to write my code specific to this cloud provider, and it's not portable, or not necessarily easily portable. And I think that's a concern for people too, that there's just no standardization.
I was typing here, but you're right. I kind of mentioned this during the presentation. There is no locking. Anytime you can basically move your Azure functions to somewhere else. However, if you're using the native bindings, for example, your Azure function will get triggered when something or a new blob is stored in your Azure storage account, right? We are talking about integration between Azure service. If you want to run somewhere else, you won't have this integration, right? But you basically will rewrite and replace from what it's equivalent in the other provider. And to be honest, I never faced a situation like this where we basically migrate just the serverless from one provider to another. I saw customers moving from one cloud provider to another, but moving everything, right? But here in US, at least for very large companies, what I've seen is multi-cloud. So they don't have everything in only one. They have things running in GCP, things running in AWS, but not exactly to solve the same problem. Sorry, there was a question here from Nate Jenkins. When do you think it's appropriate to use lodge cap versus a function? This is a good question as well. The lodge caps, it's already offered to you hundreds of connectors. And the connector, it already implements and encapsulates the authentication and the logic to consume the API that you want to integrate. So for example, if you want to integrate with Salesforce, or if you want to integrate with, I don't know, SendGrid, or if you want to integrate with Twitter, Facebook, right? You have two options. The first one, you need to subscribe and consume their APIs by your own writing code. Then you should use Azure Function. Or you can use these connectors available on Logic Apps and basically drag and drop those components, those connectors, sorry, and create your workflow. So in summary, if you want to integrate to something that already exists in Logic Apps, maybe Logic App will be good for you. Or if you want to, write the code by yourself, which will integrate with those services, Azure Functions will be the right one. I don't have the right answer. It will depend on your scenario as well, if you are familiar with programming or not. AWS has something like SAM for DevTools and IDE. Is there a equivalent for Azure? Where is SAM? I'm not familiar with this service. Do you know what it is, Jeff? SAM? Let me just...
AWS has something like, yeah, I don't know. I mean, I use AWS quite a bit, but I'm not sure what SAM is. Hey, Louis, do you want to go ahead and unmute and talk?
Can you hear me?
Yes.
Okay, yeah, SAM.
Yep.
So if you just Google it, it's the serverless application model. It's specific to AWS. They provide a full IDE CLI tool where you can just build serverless applications. I wonder if there's something equivalent in Azure Functions.
I see. Yeah, so for Azure, we have Azure Functions CLI, but it will be only for bootstrapping your Azure Functions. For workflows, as far as I know, you can use the Visual Studio or Visual Studio code to create your workflows, but I don't think it's exactly the same of this one. I think I know what you're talking about. This one is basically you describe the workflow using YAML. Is that correct?
Yeah.
Yeah, no, we don't have something like this. Even one of the engineers of Microsoft tweet about this, mentioning, hey, they have this now, but Microsoft, as far as I know, they don't have yet. The closest one will be Logic Apps, but it's not exactly the same.
Okay. Can I ask a different question?
Sure, as many as you want.
Yeah. Okay, so AWS this week in reInvent announced running container image inside Lambda. So you don't have to write your code. You just plop in your Docker image and you run it in functions. Is there something that we equivalent in Azure?
Yeah, so there is one official image for Azure Functions where you can clone and basically start from there. But as I said, it's only useful assuming that you want to use HTTP trigger. If you want to use any other trigger or the bindings, there won't be an image for that because it's basically only lives inside Azure. So if you go to Docker Hub, there is just let me Google for you. Just a second. Docker Hub. There is a Azure Functions. This one. There is this official image, but as I said, it only works basically for HTTP trigger. I don't think it's really useful.
Okay, thank you.
No problem. You're welcome. Any more questions? Something that I forgot to mention and you want to know, maybe? While that, let me see if I can find the article that I was mentioning, because it's really amazing.
If anyone's got any questions that they think of, or they wish they'd have asked, or reviewed the video and looked back over, I'm sure Tiago would be happy to answer those questions in the future. It's just
Sure.
think of anything.
You guys have my social networks, so feel free to send a message or your question in case you remember something.
Superb.